Okay, so we're now going to install Replicator G on Windows. If you're running a version of Windows 8 or later and it's a 64-bit version, there is a little step you have to do first, which is to disable driver signature enforcement. These are not signed drivers, and therefore the only way we can install them is to disable that setting. There is a YouTube video that shows how to do that, which is linked in the manual, and there are other articles on the web that show how to do that. It's pretty straightforward. It's a little bit different for Windows 8 and Windows 8.1 in terms of how you get to that setting, so just Google how to disable driver enforcement for Windows 8 or 8.1, depending on what you have, and you'll find simple instructions for doing that. I've already gone ahead and done that on this computer, and so now we are ready to go ahead and download a little prerequisite, which is called PyPy. This is a Python interpreter, which is needed to run the slicing software that's part of Replicator G. That portion of the software is called SkeenForge. That's actually the slicing engine that is included with Replicator G, and that needs a Python interpreter to run. So we are going to go and download PyPy, which is a free download, and PyPy is a lot faster than the original version of the Python interpreter. So you can get this from pypy.org. Alright, so here we are on the PyPy download page, and what you want is right down here the default with just-in-time compiler. So there's a link right here for the download. That takes you down to the list of different versions, and we of course want the Windows binary. In this case they only have a 32-bit version, so we'll go ahead and download that even though we're running 64-bit Windows. That's fine. So that is downloading. Notice that it says you might need this other download, which is a Microsoft download, which is some Visual C support files. So we're going to go ahead and download that also. And both of those are now downloaded. So we're going to go ahead and do this through Explorer, in case you're not using Chrome for your browser. So we'll go to our downloads, going to unzip the PyPy download, and in this case there is no installation. We're just going to select all of the files and subfolders that are within that, copy those, and going to now paste them into a directory of our choice. I'll just put these on the C drive, create a new folder called PyPy, and I'm going to paste these files into there. It's a lot of files to copy, but that's all there is to installing this. There's no real setup program, so just need to let these copy over. While that's going, I'm going to switch back to my browser and go ahead and download the next piece, which is Replicator G. So now that we have downloaded PyPy, we're going to go to another website, which is Replicat, without an E at the end, replicat.org. And right at the top of the page here is a link for their version 0040. Now a quick note here, if you have plans to upgrade to the sailfish firmware, which is covered elsewhere in this video, you should consider downloading the other version of Replicator G, which is found on thingiverse.com, and you can find details about that in the instructions in our companion manual, as well as in the sailfish instructions if you search them out on the web. So for now, I'm going to go ahead and use the default version, and we'll show you the other parts later. So we'll click here. You'll see that there are versions for Windows, Mac, and Linux. We're going to go ahead and download the Windows executable. Click here to download that 78 meg file, so that'll take a moment. Meanwhile, my PyPy files have finished copying over, so we now have a full copy of PyPy located under C /pi. Just going to close that for now. We just need to know where that is. You can put it anywhere, but we will need to know that location for later. I do not recall if I installed the Visual C package here on this computer, so I'm going to go ahead and install that as well. Yes to accept the terms, install. And that's all there is to that one. And now that Replicator G has finished downloading, we'll go to that installer, just run that. And I'm going to go ahead and choose the default directory. You can put it where you like. Now, it's checking for Python, and it says it looks like you don't have Python because we're using a different version. That's okay. Just ignore this and click Install. Copies all the files over. Alright, and as you see here, it is now installing our drivers. So we click Next. And we're going to give it permission to install this. And another pop-up that we will allow for the installation of these. There's just multiple driver files, and so we are going to continue to give it permission. And as you can see here, it successfully was able to install a variety of drivers, and that's going to let us communicate through the USB port with our printer. So we'll click Finish here, and it shows that our installation is now completed, so we click Next, and now we have Replicator G installed. Now the first thing that we need to do is run Replicator G and tell it where we have that /pi program installed. So to do that, let's see, I do not recall if a shortcut is created here for us. Yes, there it is. So we'll go ahead and run Replicator G. Okay, so the first thing that you want to do is go to File, Preferences, go over to the Advanced tab, and there's a button down here that says Select Python Interpreter. And we want to click that button and tell it where we put that /pi software. So in my case, that's the C drive in the /pi folder. You can choose wherever yours is. Select that file, the /pi.exe file, and choose Open. Then click the Close button to save that setting, and we are now ready to proceed. Now there are some sample files that you can try out under File, Examples. You'll find things like a little calibration box and some other simpler objects. I'm going to go ahead and print this little bird in a cage, and we'll do this in each of several different pieces of software so that we can compare the results. And you'll notice not all objects end up right in the middle of the build plate where we might want. You can use these controls over here to rotate the object, move the object, do whatever you might like. In this case, I'm going to select Move and then Center. And you might want to go ahead and click Put on Platform to make sure that it's sitting flat on the bed as well. You can also do things like scale the object up or down by a certain multiplier. You can mirror an object to flip it in different directions. Once you have everything set the way you want, click on Generate G-code. We're getting a warning that we've made some changes. We might want to save that. So yes, I'll go ahead and save the changes. That will include the positioning information. And now we are presented with a screen to choose our print settings, our slicing settings. The top setting is where you choose which profile you want, and we want the Replicator slicing defaults because the FlashForge printers are based on the Replicator design, and therefore those settings are going to work for us. We want to use the right extruder. That's generally considered primary, although you can use the left if you prefer. We can choose whether to use raft or support. In this case, I don't need either. If you do want support, you can choose either exterior only or full support. In this case, we want to use the default start and end G-code, and we want to use this print-o-matic feature, which is these simplified settings down here, instead of going into the full detailed advanced options. So now to look down here at these settings, there's a few important ones. The infill percentage, you're usually going to want that between 10 and 20%. This is how much of the interior of the object is actually filled in with plastic. You don't need to print most objects with 100% solid infill. In most cases, as I said, 10 to 20% will be plenty, so we'll use 15 here. Layer height is essentially your resolution. I use 0.2 millimeters as a sort of default. That's a nice medium/medium high resolution. The FlashForge printers are capable of going at least twice that high. They say on their website that it's capable of 0.1 millimeter resolution, but I have used both the Creator and the Creator X to print at 0.05 millimeters and have gotten very good results. So these printers are capable of very high resolution, but the print speed slows down significantly because there's many more layers to print when you go to those higher resolutions. So I'd suggest starting with 0.2 millimeters. Number of shells indicates the wall thickness of your object. How many layers do you want on the outside perimeters, and that determines the thickness of that outer shell. So usually 1 or 2 is the appropriate value. I like to use 2, so it's a little bit thicker, but 1 is okay in most cases. Feed rate is essentially your print speed. I would suggest starting with something pretty conservative. I'm using about 60 millimeters per second here. These printers can certainly go significantly faster than that. I normally print at around 85 millimeters per second, and if it's a simpler object, I'll even go faster than that. But for your first print, you'll want to keep it a little bit slower just to make sure everything's working okay. Travel feed rate is the speed at which the extruder moves when it's not printing, so moving between different print positions. And you want that to be as fast as possible because then there won't be time for any plastic to leak out of the extruder, and it'll keep your prints cleaner. So these printers are very capable of 150 millimeters per second, even a little more, but I use 150. Print temperature depends on your material. For ABS, let's use 230. If you were using PLA, I would suggest 190. These are temperatures in Celsius. Then we go to plastic, and that's where you define the diameter of your filament. Now, you would expect this to be 1.75, and that might be what you want to start with. But I suggest that you measure your filament in each particular case when you change spools, because you will find that there are slight variances. So if you use a digital caliper to measure the diameter at a number of different points, I'd say 4 or 5 different places, and then average those values together, you should enter that measurement in here, and you will get higher quality prints because it knows exactly how much it needs to push that filament through for every so much movement of the extruder. So it knows exactly how much extrusion to use. When you then go to the extruder tab, you'll see that it's just defining the nozzle diameter. For the FlashForge printers, that should be 0.4 millimeters. That's about all we have to do now, so we'll go to Generate G-code. And in this case, it's just giving us a warning that we are slicing at accelerated build speeds. That's fine because the FlashForge printers are very capable of that. We'll click OK. You can turn off that warning from your preferences later if you wish. And as you see now, it is slicing the file. It goes through various different parts of the process as reported here, and it goes through all of the layers for each part of the process. So in our case, we have 133 layers, and it has a couple more pieces to do, and then it will be ready. And now it looks like our file has been exported. You can see that down in the status window below here, and you'll notice up above that we have a new tab that says G-code. If we go to that, you'll see the G-code that has been generated. And this doesn't need to make any sense, but these are the instructions that are going to be sent to the printer to tell it what to do and how to print our object. So the FlashForge, because these are MakerBot type printers, Replicator type printers, these need to receive their instructions in a different file format, not G-code, but what's called an X3G file. So to do that, we use this button up here that says Build to File for use with sdcard. When you click on that button, you'll be given an option for where to generate your file. You want to be sure to look down here for the file type and make sure that it is set to X3G and not S3G, because the FlashForge printers are running a current enough firmware that they are expecting the X3G file format. And we will then choose a location. I'll just let this go to the desktop, save, and you'll see that it's building that file, and now it's finished. We see over on the desktop here that we have our bird in cage X3G file, and that can now be copied to the SD card, placed in the printer, and we can do our first test print. You can also do prints directly from your computer. I typically don't do that, and I would suggest that you be careful, because especially with longer prints, if your computer fails for some reason, like if your operating system crashes or freezes, your print job will fail, and there's no way really to resume that if that happens. So I prefer to print from SD card so that the printer is entirely independent, but that is entirely up to you. So we will show here how to go ahead and connect up the printer and run a print job from the Replicator G interface as well. So I'll go ahead and connect the printer up to the USB port. I'm going to go ahead and exit out of Replicator G. Now I'll run it again. And as you can see, it's already connected. Now, in your case, if it does not automatically connect, that just means that it hasn't seen the serial port that it's connected to. So if you go to the Machine menu, Connection, Serial Port, and choose Rescan Serial Ports, it should then find that port that it's connected to, and you should be able to select it here. Also be sure to select under the same Machine menu, Machine Type should be set on the Replicator Dual. If it's not, make sure to choose that. At that point, you should be able to connect. If it didn't do so automatically, you can do so with this button that looks like a plug going in. And then this bar up here should turn green to indicate that you are connected. When you press this little cross-looking symbol here, the one that looks like a navigational arrows, you'll find yourself at a control panel. And this is a handy little way of manually controlling the printer from your computer and monitoring its temperatures and what it's doing. So up here in the upper left, you have controls for moving the extruders around in the X, Y, or Z dimensions. So you would be able to move the build plate up or down using these blue arrows. You can move the extruders side to side using the green arrows. And you can move them back and forward using the red arrows over here. You can also do an emergency stop. If anything goes wrong, just click this button and everything stops immediately on the printer. You can also use the jog mode, and choosing this here, you can choose how fast it goes, or how far it goes rather. So when you choose to jog using these controls over here, you can have it go in 1 millimeter movements, 5 millimeter, 10, etc. Or you can have it go continuously, in which case you just hold down these buttons and it will move continuously until you let go. Using these sliders, you can choose how fast you want the extruder heads to move in the XY dimensions. I wouldn't go too fast, keep it slow at the beginning, and then you can speed it up a little bit to see what you're comfortable with. I would not go beyond about probably 7,000 or 8,000 millimeters per minute, but that's pretty fast, so most of you would want to keep it slower. The Z speed you'd want to keep pretty slow as well, but you can raise it somewhat. Keep it at one of these mid-range values, but that's determining how fast the bed moves up and down. You can enable or disable the stepper motors. When the stepper motors are disabled, you can then move the extruder heads around freely using your hands. Then over here on the right side, you can choose your preheating temperatures. And as soon as you put in a temperature for the right extruder, left extruder, or the heated build plate, it will begin to heat up to that temperature. So as you can see down here on the chart, my printer is already preheated. What you would see is a pink line indicating your target temperature, and the red line indicating the current temperature of the right extruder. And in my case, those are both the same because I'm already at target temperature. There's a blue line for the target for the left, which I have at 0 because I won't be using it, and a dark blue line for the current temperature on the left. We have a yellow line for the target temperature of the build platform, and a green line for the current temperature of the build platform. Again, we only see a green line down here because it is at the target temperature currently. So you can use this to visually monitor the temperatures and make sure that everything is up to speed. And now that it is, we can go ahead and close down the control panel and get ready for our first print. Because the printer is connected, you'll see that we have these additional two buttons on the left, which is build the object on the machine or build from the SD card in the printer. Generally, I do not recommend doing the SD card prints from here. It's better to do those from the LCD panel, but you can start a print job from Replicator G if you'd like to do so from here. So clicking this button, it's running some final checks, and it is now beginning the build process. And that's all there is to it for a single extruder print. After this one finishes, we'll take a look at how to do a dual extrusion test print from Replicator G. Okay, now we're going to go ahead and do a dual extrusion test print. Again, under the File menu, Examples, you will find a couple that you can do right here under Dual, but I'm going to go ahead and use an object from Thingiverse, these little traffic cones here, and what you can see is there's two different files, and this is the way dual extrusion works. You need to have one model for each extruder, and the software is going to sort of merge these together, and each one of these will be printed in a different color. So in Replicator G, the way you do a dual extrusion print is under the G-code menu. You choose this option down here, Merge STL for Dual Extrusion. And what you need to do is provide two different STL files, one for the left and one for the right extruder, and then tell it what you want to save the merged file as. So I currently have my orange ABS loaded for my right extruder, and I went ahead and loaded some white ABS in the left for this print. So on the left extruder, I'm going to select the white part of the object, which is named accordingly. For the right extruder, I'm going to choose the orange part. And then for Save As, I'll just tell it to go to my desktop, and I'll call it traffic_cone. Save. And then I click the Merge button. Okay, and as you can see, we are presented with two settings windows, and that is one for each extruder. You can see up on the top, one of these is my white part, and the other is the orange part. And all we're going to do here is you want to make sure that Use Raft and Support is unchecked for this, because those can kind of interfere with each other in a dual extrusion print. And the rest of these we're going to leave just as we had it set up before, pretty default values for an ABS print. And so I'm going to go ahead and choose Generate G-code in each one of these. And this is just that accelerated build warning again. You can disable this under File Preferences. And I'm going to do the same thing with my other settings, making sure RAF support is off, and then Generate G-code. Acknowledge the warning, and now we have both of those running. As you can see, there's two different slicing processes, and then there's a third window that is basically waiting for those to complete. Okay, now our files have been merged, and we are looking at the G-code file that resulted from that. From here on out, the process is the same. We can use this third button in to generate a file for our SD card, or we can use the first button to go ahead and start building it directly from the computer. In this case, I will go ahead and do it directly, though I normally print from the SD card. We already have the filament loaded, and I already have the printer preheated, so this print job should get going right away. And that's about all there is to it. So we've now done a single extrusion and dual extrusion print from Replicator G on Windows.